Russ Herrell is a distinguished technologist and has been with HP for almost 38 years. He has designed ECC memory boards, 3D graphics accelerators, virtual DMA interfaces, and also load store graphics library interfaces. Oh, the list goes on. Most recently, Russ has been working to enable Gen Z, which I think he'll talk to us later today about, and also memory-driven compute ecosystem. Russ has received his master's in electrical engineering from Montana State University, and he's been with HP ever since leaving the campus. Russ, the floor is yours.
Thank you, Divya. Welcome, everybody. Welcome to our session on an open fabric management architecture. In the session, we're going to try to answer these questions. What is an open fabric management architecture? Why do we need one? And where do we start? Next slide. So let's jump right into the problem statement. The industry has too many tool stacks running on the top of a variety of fabrics. There's everything from Ethernet, Fiber Channel, InfiniBand, PCI Express, and there's a variety of applications and libraries and tool stacks that want to use these fabrics. And each fabric has its strengths and its own management tools. And then there are more fabrics and other things coming soon. There's new fabrics such as Gen Z. There's new fabric features such as fabric attached memory. And there are new compute resources such as pooled accelerators. And solution providers are faced with this diverse resources that need to be connected via one or more fabrics to deliver a complete solution. Yet there are no common interfaces among all the different tool stacks and fabric managers, and so there's little interoperability. Next slide, please. So let's take a look at the current state of affairs. And here we'll introduce the actors or players involved in delivering a solution to a client. So first, their client on the left is the end user of a total solution. Client relies on the application delivered to their access point. The application developer creates the software suite, which the client uses, and the developer relies on a different set of applications known as development tools. And then the solution provider integrates the client's applications with the appropriate delivery platform and runtime resources, usually over a fabric. The solution provider relies on yet another set of applications known as orchestration and automation tools. Now, since this is a discussion of fabric management stacks, let's look at the different players' needs that the stacks must meet. Next slide, please. Of course, the application is delivered as part of a total execution stack, but the client only sees the light blue items over there on the right. That's all they care about. That's all they really want to pay for, just the apps. The items in the solution stack that are in the deep blue shadows are just that, items they don't want to deal with and shouldn't need to care about. Next slide, please. Now, the solution provider has to understand more of the stack, and here the solution provider is writing an app that will run on many different platforms because they chose to code to a standard fabric library, and in this case, we show it as libfabric. App developers like libraries. In fact, the fabric exists only because the library exists. The library exists to meet the application's requirements. The developer uses the library so the code is portable, and then the customer intent defines the required platform and fabric characteristics that are required at runtime. So the solution provider may choose to optimize their app to make use of a fabric-specific behavior available from a specific fabric provider. But generally, they don't use library calls that only work on a specific fabric if they're going for true portability. She or he may then recommend running the application on top of different fabrics based on which attributes, like cost, performance, reliability, map best to the client's needs. So the client and the application developer are usually happy not knowing too much about the specific fabric. Next slide, please. However, the solution provider has visibility to too many stacks. He or she relies heavily on automation tools and orchestration tools. Their desired working model is to launch appropriate application jobs on suitable virtual platforms via use of such tools. These tools ingest the request, interpret the customer's intent from the constraints given with the request, and configure the software application stack, the platforms, and hopefully the Fabric hardware itself to deliver what the client is seeking. But orchestration and composition tools are getting quite good at configuring compute, storage, and memory resources on individual servers. However, when multiple servers or remote storage need to be connected, most tools can only automate the configuration of an Ethernet fabric to do so. Other fabrics may require manual configuration. Next slide, please. So the application developer was careful to write the application on top of a standard library over there on the right, but the solution provider tools do not often speak fabric configuration. So the solution provider ends up also serving as a fabric admin and performing setup of a fabric manually via a very fabric-specific fabric manager. Now, most fabrics share the need of several common fabric-level configuration and management functions, as you see there in the center: route and topology management, addressing and firewall and partitioning, fabric address assignment, discovery, and enumeration of fabric resources. However, each fabric implements these management functions differently, sometimes quite differently. So the orchestration and composing tool applications need a common interface to invoke common fabric management functions. One doesn't exist. Fortunately, the OFA knows a thing or two about such things. Next slide. So let's look at this fabric software stack from the OFA viewpoint. On the left, the OFA provided application developers a fabric-agnostic message passing, remote memory accessing programming interface. So libfabric provides a common library and API to present fabric data plane services to applications and middleware. Libfabric was defined based on the needs of the developers for those fabric data plane services. Now, fabric-specific providers convert the standard interface calls into fabric-specific traffic. So the application writer doesn't deal with anything in the deep blue shadows. On the right, what we would like to have, the solution provider also needs their tool stack to have a similar level of fabric independence. The OFA could provide a common fabric management framework and interface to present fabric control plane services to orchestration and composition applications. The framework capabilities would be defined by solution provider needs, and the fabric-specific fabric manager providers would generate the appropriate fabric-specific management traffic to set up the fabric control planes. If the orchestration and composing application developers have such a fabric-agnostic fabric management interface to program with, next slide, and the solution provider no longer sees those low-level fabric details. The developers of the orchestration and composing applications can affect fabric configuration changes via the fabric-specific providers through the library calls or the interface calls. So what does this standardized fabric manager framework look like? What are its requirements? Next slide, please. Let's be clear about what our fabric contains. First, there are hosts. These are really bridges that enable threads of execution to establish some state or maintain some state on various fabric endpoints or the host bridges, and manipulate data or move data. And then there are the fabric switches, which generally just pass through or relay packets, but sometimes do some processing or filtering of packets as they flow through. often part of the shared infrastructure on a multi-host, multi-tenant fabric, and therefore switches are generally not under control of any one client. And switches come in different flavors. They can be symmetric, where you can plug any type of endpoint into any port, or they can be specific, where certain types of endpoints can plug into certain ports. And then there are endpoints. Other than host bridges, endpoints implement some other resource or service and map it to the fabric. Memory modules, storage modules, processors. A single tenant device generally can't maintain multiple contexts and therefore can't discern different permissions for different requests or different requesters. Multi-tenant devices can, so they may be shared either sequentially or in parallel among multiple hosts. And you might call them requesters, initiators, masters, hosts. But multi-tenant devices will have multiple masters of contexts. How do we manage all of these things? That's the big question. And that's the next slide. So this slide visually shows the Universal Fabric Manager stack over there on the right, while the text defines some requirements and some functionalities. First, the objectives. Provide a northbound interface to describe the fabric and its resources and services. Provide a model for those applications to reference the fabric with. Allow clients of the model and the services to control host, fabric, and endpoint resources by manipulating the fabric model and applying actions to the model. And then enable fabric-specific providers to program for a common set of APIs. So the trick is to have a model whose objects have sufficient state and necessary controls and actions such that the generic model manipulation will achieve the desired state or configuration of the actual fabric components. So if you look at the typical fabric functions that need to be supplied by the manager, we recognize that many of these functions are common. If you go through that list, crawling the fabric and discovering components, publishing the resulting resource inventory so tools know what's out there, and authorizing accessing and mapping resources to the fabric, enabling routes and paths and connections among the endpoints. These are common traits, common functions that need to be done. If we had a common data model for representing fabric resources, and we create common actions that we can apply to the model elements, we would have what we need. It starts with a common data model. We need one, and where can we get one? Well, next slide.
Russ, there is a question, if I may bring up now.
How are we doing on time? Yeah, we can make it
Okay.
a quick one.
Yeah, I think this is important because it's terminology related. It's better to get it answered. In your definition of a common framework, how would you define an Ethernet network of identical peers?
I'm not exactly sure what the question is, so maybe we should push that off.
Yeah. Chris, your mic is open if you like to add some comments.
Yeah, I mean, in your framework, I mean, do you allow for the definition of something like an Ethernet fabric of identical peers? Because you showed a CPU and a disaggregated devices. So I'm just trying to understand if this applies to all general.
Yes, it should. The switches would therefore all be symmetric ports, and you would have requesters and responders or initiators and targets on each port. Each Ethernet device or NIC would be both a requester and a responder or initiator and target. And the REDFISH fabric model would represent those endpoints with both types of attributes, and then you would manage those attributes. That's about all I can say in this short period of time. Yeah. So as this slide implies, REDFISH is an industry standard which gives the various orchestration and automation layers a common data model for dealing with different fabrics. REDFISH describes all fabric resources as objects, and the resource state and configuration is managed by manipulating the resource objects. So REDFISH gives the M fabrics a single API for dealing with N orchestration and automation layers. But REDFISH does not define how to make the objects work together to enable fabric behavior. For example, REDFISH currently allows a client to update route tables on a switch port, thereby enabling traffic to flow through the switch. However, there is no action in the REDFISH schema that would make all the changes to all the switch ports and endpoint controls that would establish a route between endpoint A and endpoint B as a result of a single call. So if we analyze the common duties as implied by our stack picture and the previous slide's texts, we can create a set of common actions for the REDFISH objects. Upper layer tools can invoke such an action on the fabric. Hang on, I have got to shut this stupid clock off. Apologize for that. I forgot all about it. It was there. I don't hear it normally. So the upper layer tools can invoke such actions on the objects within the REDFISH model, and then the fabric specific provider can realize that functionality as appropriate to the given fabric. Now, for some fabrics, that southbound interface out of the framework layer will also be standardized for that fabric, so we don't have to reinvent a lot of that. So we propose REDFISH as the standardized fabric model. Next slide, please. So what is REDFISH? We don't have time to do much with REDFISH description here. You can read the details on this slide later. Verbally, here's what's important about REDFISH for today. It's a REDFISH API. It's a RESTful API. It provides a schema and data models for almost everything in the data center, including the ancillary functions like permission tracking, logging, etc. It has a fabric model defined to represent multiple fabric flavors. Ethernet is one of them, I believe. Works with the major standards bodies of the resources to create efficient and accurate resource models. So REDFISH is architected to be the common data model we need. That's its charter. We also need a specific fabric to test the model and the management framework against, and allow us to build the things that might be missing at the moment. So hence we propose the Gen Z consortium work with DMTF on REDFISH fabric model as a strawman starting point for the northbound interface feature set. Next slide, please. So why Gen Z? Well, Gen Z fabric is proposed as the first test case because it has elements of many fabrics included. So it looks like the union of a lot of requirements. It has memory semantics and control surfaces appropriate to these new endpoints that come with this feature. Memory semantic and fabric attached memory. Gen Z is already being used to drive enhancements to the REDFISH fabric models for these new features. Examples to the extensions being made to accommodate Gen Z are things like zones, which embody path enablement between endpoints and fabric isolation policies, address pools that dictate fabric ID assignment choices, memory chunks that embody memory regions and fine-grained access controls so that you can talk to a multi-tenant media controller from multiple hosts, and manager objects that enable multiple types of manager entities and multiple manager instances to exist for scaling and redundancy purposes. Now, in this model over here, it's just sort of a placeholder. It's a real model is way too complicated to show anything. Only the zones are shown, endpoints have to be a member of the same zone to be allowed to talk to each other. So what now? Well, on the next slide. We want the OFA to establish a work group to officially architect a universal fabric manager. It's similar in concept to libfabric. So we've outlined a significant problem. There's just too many non-interoperable fabric management tool stacks. There's a known effective approach to solving this problem. Standard library-like interfaces like libfabric need to exist for control plane applications. There's an existing starting point, REDFISH fabric models, and there's a development test case, the Gen Z fabric. So OFA and Gen Z have already agreed to investigate this universal fabric manager. Over here on the left is text right out of the agreement. Similar to libfabric, such a universal fabric manager would likely be built on a framework provider architecture, just as we've proposed. So please come to the Birds of the Feather session after the break and weigh in on your opinion on this. Help define detailed requirements for the universal fabric manager. Let's form an OFA working group to develop the universal fabric manager, and let's contribute to it. Next slide, please. So I got through that in exactly the right amount of time, which never happens. So there is time left for a question or two. Now, first of all, did the subsequent REDFISH description help answer the question about how Ethernet would be handled in this universal fabric manager? Are we good to go on that question?
I believe so. Chris, your mic is open. Any follow-up thoughts on that one? I mean, we do have time to discuss if you need to.
Yeah, no, I think you answered the question. There was nothing inherent in your concept of the model that limited Ethernet or all the devices in the fabric from being peer agents to each other versus the unpeered relationship which you showed. And I think you answered that question. There's nothing that limits it in this concept. I mean, obviously, Ethernet is another test case that's interesting if you want to develop a universal fabric manager.
Yes, and Jeff Hilland will correct me if I'm wrong, but I believe that REDFISH already has a working Ethernet fabric set of models.
Well, the data models are there, but you're talking about something that controls routing interfaces and other things, right? That goes beyond what that defines. Right. Yes, so again, this is an interesting test case. There's probably some others too.
Yeah, not to dive too deep into the implementations, but it's already been mapped to PCIe, Gen Z. We're working on completing underlay and overlay for Ethernet right now. So SNIA's mapped the fabric model, fiber channel, InfiniBand extensions are in progress. So never seen a fabric we didn't like. So if you have comments, bring them in.
Yeah. So we have the fabric models. What we need are the fabric actions and functionalities represented in some form of actions, or I'm not sure what you would call them in REDFISH. I just call them actions, but some way to request it.
Yeah, what's the tricky part, right? I mean, there's already a fairly sophisticated, defined way of doing this in SDN infrastructure, right? So it'd be interesting to see how that's accommodated.
Yeah, more reason to form a working group and have the detailed discussions and list out the requirements.
I do believe it will work.
Cool. Thank you. Any other questions for Russ? Or Jeff is also now participating. So any questions for the two? On this topic, I think Russ will continue discussing with us about Gen Z in the next half hour. But before we dive into Gen Z wanted to know if any questions on the Open Fabric management architecture. Okay, so if that's it, then I just, for folks who joined late, I would just like to remind Russ, the speaker of the next session, also the speaker of our previous session, is now going to talk about Gen Z. He is a distinguished technologist and has been with HP for 38 years. He's worked on multiple technologies and designed ECC memory boards, 3D graphics accelerators, interrupt-driven flow controls, load store graphics, or the list goes on. But here, Russ, is your opportunity to talk about Gen Z. Before we go to that topic, I got some messages about presentations for today.